Hey, 6th grade, we have our second 9 weeks end test this Friday and next Monday. So let's jump into it and do some of our review questions. So number 1 says, Mrs. Kemp is looking at the test results for 5 students in her class. Kim got 1/3 of her test questions correct. Brooke got 9/24 of her test questions correct. Melanie got 5/6 of her test questions correct. And Bailey got 3/4 of her test questions correct. Ms. Kemp arranged the test scores from least amount of questions correct to most amount. In what order did Ms. Kemp arrange the test scores? So I've got some fractions here. We've got Kim's We've got Kim's fraction. Sorry, y'all. We've got Melanie's fraction, Brooke's, and Bailey's. And it said that we want to go in order from, what did it say?
Least amount?
Least amount to most amount. There we go. So we're going from L to G. So I'm going to write that right here. Make my ladder. Okay. And got 1/3 for Kim.
That's a benchmark. It's 0.3 repeating.
Repeating, little line.
1/3. We have 9/24 for Brooke. 5/6 for Melanie. And 3/4 for Bailey.
Which is
That's
also a benchmark, yes.
What are we doing? We want to do decimals?
Decimals.
Okay.
I did fractions.
I did fractions too. I wanted to get a common denominator of 24, but we'll make Miss Kemp happy. Okay. So 1/3, Miss Kemp already told us the 3's repeat. So this is 0.3 forever and ever and ever. We know 3/4. We talk about quarters. That's 75 cents. Okay, and then 9/24 I do not
You can
know.
simplify by 3.
Oh, can we?
Yes.
Let's do it.
That'll be a benchmark.
It will be a benchmark.
Oh, thank you, Miss Reynolds. Saving me time here. Okay, so we've got 3/8.
Yeah.
That's 0.375.
0.3. Oh my gosh. I missed my pen. 0.375. Okay, and then 5/6. I've got to divide out Menonito. Put 5 in the house, 6 outside. Can't go in there any. Whoops. Raise my roof. 6 can go into 50. 8 times.
48.
6 and 8 went on a date and on their plate. It's 48. 2. Bring down. 6 can go to 23 times, which is 18. Oh my gosh.
Yeah, I see this not going well for me.
Okay, and then it looks like it's going to keep repeating with the 3. So we're going to leave it like that. Okay, and if we're thinking about money, I want to know the least amount of money is going to be
33 cents.
33 cents.
1/3.
Then we've got the 37 cents.
9/24.
And then
And through 75 cents. And then 83 cents. So then you would list them in order on the line, which I'm not going to do because y'all can see what to do. Whew, that was a struggle.
Okay. Oh, I forgot. We got to touch the little finger to scroll it down. Okay, for this one, there are 7 points on the number line, and it's saying which one represents the value of the absolute value of -3. Remember, absolute value is already asking you a question. You must do the absolute value of -3 first before you plot it on the number line. So absolute value is the positive of whatever is inside. So the positive version of -3 would be
Positive
3.
3.
So if I look on my number line, the only one that says 3 is R. So my answer is B. Okay, number next. Let's see. Little finger.
Yeah.
Scroll.
Good job.
Okay.
And then 10. Okay. Miss Rose worked 15.5 hours last week at a bakery. She made $9.50 an hour. Miss Neal worked 18 hours last week at a fast food restaurant. She made $8.25 an hour. What is the difference between the two amounts that Miss Rose and Miss Neal earned last week? Okay, so first we got to figure out what Miss Rose made. Let's see.
This is like 3 steps.
Oh, yeah, this is
y'all.
a 3-stepper.
Okay, so 15.5, they have it in a fraction, but we can easily make that into a decimal with 15.5.
5.
We don't need that 0, trash him. And she made $9.50. We're going to do 9.5 on that one. Correct?
Yes.
Okay, now we go through and multiply. 5 times 5 is 25. Carry the 2. 5 times 5 is 25 plus 2, 27. Okay. And then 5 times 1 is 5, plus 2 is 7. And then do not forget to put your placeholder
Placeholder
0
0.
before we can move on. Okay, I'm going to try to change the color so you can see. Okay, now let's move on to 9s. 9 times 5 is 45? No, yes.
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 Okay,
Agreed.
9 times 5 is 45.
Carry the 4.
And then 9 times 5 again is 45 plus 4, 45, 46, 47, 48, 49. Carry the 4. 9 times 1 is 9 plus 4, 13. Now we add them all up. I feel like I'm making this way too big.
It's okay. We can erase it if we have to.
5 plus 0 is 5. 7 plus 5, that's 12.
Mm-hmm.
Whoa, I like doing quick math. Okay, and that's 19?
17.
17?
17.
Never mind. Don't do quick math. Okay. 3 plus 1 is 4. Plus 1 is 1. Okay. And now before we move on, do not forget your brick wall. We got to go 1 plus, and then this one goes 1. So then therefore from my brick wall, I am going to move 2 times. 1, 2. So my answer for that one for Miss Rose is going to be $147.25. Woo!
Whoop, whoop.
That's a lot of money.
Go Miss Rose.
I got I think this is the eraser.
Yeah.
Oh,
You're
I
good.
thought
You're
I
good.
erased the letters. Okay, I got scared. Okay, now
Miss Neal.
Miss Neal,
Whoop,
she worked 18 hours, for $8.25. Oh
No,
my.
fair. I didn't get paid enough.
Yeah.
Miss Rose got more money.
Let's put the $8.25 on the top because it's
That's
got
like a
more.
3 digit.
That's
Yeah.
3 digits.
Good strategy, Miss Kemp.
And then 18 was at the bottom. Okay, 8 times 5.
40.
That is 40. 8 times 2, that is
16.
Plus 4,
20.
that is 20. And 8 times 8 is 64, plus 2, 66.
Mm-hmm.
And then we got a
Placeholder.
placeholder 0 before we can move on. Then we can move on. I'm going to switch colors so we don't get confused. And now, 1 is easy. 1 times 5 is 5. 1 times 2 is 2. And 1 times 8 is 8. Then we add them all up. That's 0. That's 5, 6, 7, 8. And then 8, 9, 10, 11, 12, 13, 14. Sorry, I can't do quick math. Then I mess up. Okay, now again, brick wall, do not forget. We're going to do 1, 2. So therefore, from my brick wall, I'm going twice. Right?
Mm-hmm.
1,
Yep.
2. So then my answer for Miss Neal is going to be 140.
Ooh, I beat Miss Rose.
You did, and you made less money.
You worked
And
longer.
50
Yeah.
cents.
Man.
So then we're going to minus these to get the difference, but I can minus in my head, and I know that is $1.25.
Ooh.
Yes.
I'm going to show her how to.
And then we move on.
Y'all,
And then
Touch the pen.
touch the pen to write.
Anywhere,
The pen.
pin.
Oh, yeah.
Hey guys, just me, Miss O, learning how to use the new equipment. Okay, number 4 says, look at the tables below. We've got Gary's Groceries and Martin's Market. They have apples and oranges and in different amounts. What is the relationship between the number of apples, A, and the number of oranges, O, for Gary's Groceries and Martin's Market? Complete the following statements by writing the answers below in the correct blanks. All right, so it looks like we got to find what's the relationship. If you had 1 apple in Gary's grocery store, then there's how many oranges? 5. Then 2 apples and then 6. So are you adding or multiplying there? Adding, yes. So it looks like plus 4 here.
Yeah.
Mhm.
Adding 4.
Yes.
Yes.
It works on all of them.
I know. Look at that. 3 plus 4, 4 plus 4. All right, let's check Martin's. If he has 5 apples, then he has 10 oranges. Ooh, that could be plus 5.
Yeah,
I don't know.
plus
Okay,
5.
let's check 10 apples and 20
No.
oranges. No.
10 plus 5 is 15.
So now I'm thinking it's multiplicative, so it's going to be times 5. Let's check the last one.
Wait,
Times
2.
5.
5.
Times
No,
2.
2. Sorry. Woo.
Because I looked at my
way
answer
ahead of
choices.
herself. She kept the 5
Good
and
thinking,
didn't
Miss
change
Kemp.
it. 15 times 2, 30. 30 times 2, 60.
Ooh, it works.
It does work. Okay, so for Gary's Groceries, the number of oranges is, what was our rule again? Oh, now I'm writing. Sorry.
Was plus 4.
Plus 4, so we're going to go 2 times, 4 times 2 more. That will be 4 more.
Good. More than means add.
For Martin's, we were at times 5, so that number of oranges is, 2 times. Good golly, that 5 is just going to haunt me. 2 times. Miss O's stuck on the 5. All right.
I believe on your test that's a drag and drop, so you would drag the correct thing into the blank.
Okay.
I'm going to say times 5 every time now.
All right, number next. The following table shows a relationship between X and Y. Which of the following equations describes the relationship between X and Y? When I'm looking at a table, I am going to
Label.
write ID.
D.
I don't need to write X, Y because the X and Y are already there. I know that my equation should start with the dependent variable. Oh, they all start with
Oh,
Y. Look
man.
at that.
Rude.
Okay, so I'm going to start right here with A, and this is 5.3 times X. Well, I'm going to look here, and 1 times anything is itself, and that does not work because it equaled 6.3, so I'm getting rid of A. For B, I'm looking at 5.8 times 1. I'm going to use that 1 again. Oh, that one didn't work either.
No.
Now I'm going to do Y equals X plus 5.3. I'm looking at this one. I'm going to use 1 again because adding 1 is easy.
Mm-hmm.
So 1 plus 5.3 is
6.3.
6.3.
Yay.
And now I'm going to check it again. 5 plus 5.3. Let me write this out for you. 5 plus 5.3.
Notice she lined up her decimals.
Mm-hmm. Oh,
That was adding and subtracting.
Yeah, adding.
Woo,
Ooh,
woo.
10.3. That looks good. And if I kept going, I think that one would check. I'm going to put a question mark right here. If I add 5.8, no, that would give me an 8 in the 10th place. I'm going to get rid of that.
Wah, wah, wah.
So my answer is
C.
ID.
The tables show relationship between X and Y for 2 data sets. So let's just kind of look at one at a time. Let's look at data set 1. Like Miss Kemp did, we're going to label our ID, our independent variable, and our dependent variable. They already have X and Y. So let's look and figure out how we're getting from our independent to our dependent. So if I'm trying to get from 1 to 4. What do I keep doing? 1 to 4.2. Well, I can either do an additive relationship or a multiplicative. If I'm adding, we could add 3.2. But if I look down here and I go from 2 to 8.4, I know 2 plus 8.4, 2 plus 3.2 is not 8.4.
No.
So that does not work. So I'm going to go back to the drawing board and I'm going to say, well, what if this is multiplicative? 1 times what is going to give me 4.2? Well, 4.2. So let's try times 4.2. Let's see if that works for number next. So 2 times 4.2, is that 8.4? Yes, it is. And 3 times 4.2, is that 12.6?
Yes.
Yes. So this looks like it's working all the way down our table. So the first one, we're multiplying by 4.2, so that's a multiplicative relationship. So just by knowing that, let's kind of look at our answer choices real quick before we move on to data set 2. It says A, both data sets show multiplicative. Maybe. Let's put a question mark there. Okay, data set 1 shows multiplicative, which y is 4.2 times x. That's what we said, so that could be it. C, both data sets show an additive. Well, we just said that data set 1 was multiplicative, so that doesn't work. Data set 1 shows an additive. Again, we just said it was multiplicative, so that doesn't work. So just by doing 1, we already have a 50-50 shot. But we know how to do data set 2, so let's look here. We're going to label our I and our D, independent, dependent. How do I get from independent to dependent? Well, if we do an additive relationship, I know 1 plus 12 is 13. Is 2 plus 12 14? Yes.
Yes.
3 plus 12 15?
Yes.
Yes, so this works. So this one's an additive relationship by adding 12. So A said both were multiplicative, which is wrong because one's additive. The second one says the first one's multiplicative and the second one is additive, which is what we have. So the answer is B.
Okay, let's look at the next one. Number 7. So in December, there were 450 customers at the grocery store. Of these, 369 of the customers at the grocery store bought gift cards. Choose the correct answer from the word bank to complete the statement. So this one, I believe I'm going to be making a fraction. So if I know there's 450 people in my grocery store, that's going to be my total. So I know that's going to go in bottom because that's my whole. Ooh, I don't know what happened there. Oh. There we go.
Rousseau's wearing off on it.
It is.
We gotta get our iPad pencil back.
And then, so of these, 369 customers at the grocery store bought gift cards. So out of the 450, let me move it up a little bit. There was 369 who got gift cards. So I know when I look at a fraction that it is going to be blank over blank. And I kind of already said it. It's going to be part over whole. So if I look at my word bank, for 450, that one's going to be my whole. And then, so that must mean my 369 is my part. Notice how they tried to trick you and they flipped the order.
Yep.
How rude.
Okay, so now it wants us to find the percent of customers in December who bought gift cards.
Fraction bar equals fraction bar.
Yes.
Woo-hoo!
We want the percent, and percent is something always over 100. So how we can do this, we can either cross multiply or find the scale. I think I'm gonna cross multiply.
I think so.
So first I'm gonna cross multiply my 369 by 100, and we know we can just add 2 zeros because we are multiplying by the 100. Whoop. My goodness. And then we can't forget about that last one. We have to divide by the 450.
Yuck.
Miss Neal, I miss your pen.
I know, I miss it too.
Okay. So it can't go into 3. It can't go into 36. It can't go into 390. But it can go into 3,690 8 times. Whoop, where'd it go? And that's going to give me 3,600 exactly. We are left with 0 minus 0 is 0. 9 minus 0, we are left with 9. That's going to cancel out. That's going to cancel out. So we have 90. Now we have to drop down that last 0. So now we have 900. And then that is twice of 450. So that's going to be times 2.
And that's exactly 900.
Yay!
Yes.
Woo!
So that's exactly 900. So we are now going to see that it's 82%.
Woohoo! Okay, number next. Let's see, number 8. Little hand. Okay, it says this year 102 students ordered a yearbook and 323 students did not order a yearbook. What percent of the students ordered a yearbook? Okay, so right off the bat, I know we're going to use fraction bar equals fraction bar, just because we're so smart like that. And then, so what they are asking, what percent of the students ordered a yearbook? Okay, so they gave us that number in the beginning, which was 102.
That's your
But they
part.
didn't give us our total. They just said these students didn't and these students did buy a yearbook. So we got to figure that out. We're going to do simple addition for that. It's going to be 102 plus 323. That's 5, that's 2, and that's 4. Now that we found our total, we can plug that into our beautiful fraction bar equals fraction bar.
I bet if you use 323 as the total, that answer would be there too. So
I
make
bet so,
sure
too.
you read
No, it will
carefully.
be.
Read
Okay.
carefully.
And then we are figuring out for a percent, and percents are always over
100.
And I'm gonna go erase this so I can do more math there. So we're gonna do, I like cross multiply.
Me too.
I like
Me
butterfly
too.
method.
Butterfly.
The one that doesn't have a partner, we are going to divide him. So 102 times 100, I know that I can just add 2 zeros in the back of that. And then I'm going to divide that by 425. Okay, big numbers, but I got you. 425 goes into 1,020 by 2 times. And that is 850.
Mm-hmm.
We're going to minus that, and that gives us
170.
go. Okay, and then I'm going to bring down my 0. And then that goes in perfectly to 4.
How beautiful. Mm-hmm.
We love perfect numbers.
At least it's nice and even.
Yeah,
Mhm.
that was nice.
So now our answer would be 24%.
Woo!
I'm going to go erase some of my work. Oh,
I know.
not right. Okay, there we go. Okay.
Letter C.
Let me just click the pencil.
All right. I do not have much room to work. Just saying.
If you want to work down on 10, you can, Miss O.
All right, I may have to. I found a Black Friday deal that offered a 40% discount off the regular price
Whoop,
of a phone
Fraction bar
case.
equals fraction bar.
Oh, you know we are.
Percent.
The amount of the discount was $6. What was the original price of the phone case? All right, so fraction bar.
Oh, 100 goes in the bottom corner.
Thank you, Miss Kemp. Now we got to make a decision here. I know my 40 goes right up here. That's
Yeah,
just
that's the
handy
percent.
dandy. He tells us
Easy
that.
peasy.
But that's $6. Listen to that sentence again. It says the amount of the discount was $6. So is that the total price or afterwards? I think that's
That's
the after,
part.
the
Yeah,
part.
That's
part
the
of it.
part we paid. We
Yes,
didn't have
that's
to
what I'm
pay
gonna
the
pay.
total amount.
All right, so I'm looking for this one. Oh, we have 3 numbers. Let's cross multiply.
Yay.
Okay, so that's 600 divided by the 40.
Oh, take off a 0.
I know, kill those zeros.
Whoop.
4 goes into 6 one time. Goes into 25. So how many? $15.
$15.
Woo-woo. Sorry I wrote on your part, Miss Kemp.
That's all right.
Yeah, I'm just not even gonna touch it, and that way I won't mess it up
Oh, I
royally.
just flipped it. Okay. So I'm going to get rid of what you wrote right here.
It
And,
was so good.
I
Why?
know.
No.
and number 10 says the science experiment needs 58.5 milligrams of baking soda. How many grams of baking soda does the experiment use?
Ooh, I love these.
I love that it is giving us a number that has a decimal already. So I'm going to
Yep.
open my handy dandy blue folder if I have one, and I'm going to look for that mnemonic device, which is King Henry doesn't usually drink chocolate milk. Okay, and I am looking at milligrams.
Mm-hmm.
Let me just cover that up for you. And I'm going to grams. Okay, so I'm going from milligrams, that would be M.
I don't see a G, Miss Kemp.
Oh, wait, I remember
Oh, it's in
the
that.
teachers kept saying the unit.
Yes.
Oh,
it's over there. You
yeah.
gotta go to the
Oh,
left.
so we're jumping 1, 2, 3 to the left. So I'm going to write my number here for you. 58.5 milligrams. I'm going to put my pencil on the decimal and I'm going to go 1, 2. Oh, this thing hates me. What do I just back it up?
Yeah,
Okay,
there you
I'm
go.
going to go
Reverse.
1, 2, 3, and I'm putting my decimal here. Do you see that empty loop-de-loop?
Ooh.
Placeholder.
I'm
Placeholder
putting
0.
a placeholder 0. And Miss Kemp loves to put the leading 0. So I'm looking for 0.058. C. Let me just cover that up for you. C.
Woo-hoo! Good job.
Okay, number next. Miss O, what's your problem?
I know. I wish I had a puppy.
Miss O's puppy weighs 6.5 pounds. The vet measures the pets in ounces. How many ounces does the puppy weigh? So we're talking about pounds and we're talking about ounces. So this time I'm not going to use my King Henry because it's not metric, it's customary. So, but I know the strategy for this is a UKS. Oh my gosh. Oh. Miss Neil's getting very frustrated. Okay.
Miss Neil will be throwing them in soon.
Okay, UKSN. So my units are found in the problem. Again, we're talking about pounds and ounces. So I've got pounds and I've got ounces. And then I know my no comes from my handy dandy formula chart. So if I look on my handy dandy formula chart, which you can have one on your test, I know that 1 pound is 16 ounces.
Woo-woo.
Okay, and again, that is found on your formula chart. You don't have to have that memorized. I need to get to 6.5 pounds. So is that going to go on top or bottom? Top. I got to line up my units. So then I've got to look and figure out what my scale is. So I'm trying to figure out how do I get from 1 pound to 6.5 pounds. Well, it looks like I'm multiplying by 6.5. Whatever I do on top,
Gotta do it on the bottom.
so I'm going to multiply times 6.5. And I'm going to come do some math over here. We've got 16 times. Okay. We're going to get through this. Times 6 and 5 tenths. There we go. 5 times 6 is 30. 5 times 1 is 5, plus 3 is 8. Don't forget our placeholder 0. Then I've got 6 times 6 is 36. 6 times 1 is 6, plus 3 is 9. Then we're going to add, this up. 0 plus 0 is 0. 8 plus 6 is 14. 9 plus 1 is 10. Don't forget about my kids in my car. Ooh, go back.
Yes.
Kids in my car. I've got 0 here and 1 here, so I need to move my decimal place 1 time. Bloop. So this should be 104 ounces, which is answer choice D.
Woo-hoo.
Okay. Let's take a look at the next one. So Miss Kemp and Miss J are building a desk that is 6 feet long. Which of the following are equivalent to 6 feet? I'm going to go ahead and write a 6 on top of that 6. just to
Kemp
make
and
me
Miss
feel
J,
better.
y'all are so handy.
Yeah.
Building desks.
We're just builders.
Okay. So for this one, let's see. I'm going to take a quick glance at my answer choices. And it looks like it only wants me to turn them into inches or yards. So first, I want to look at my handy dandy formula chart. I know I'm starting with feet. So if I look at inches, I know there are 12 inches for every 1 foot.
Like a ruler.
And I know if I look at yards, my formula chart tells me that there are 3 yards.
3 feet.
Sorry, yes, 3 feet for every 1 yard. Okay. So now I have to set up a proportion or a UKSN where I have, what do we want to start with, feet or yards? Let's start with feet.
Okay, I think so.
In inches.
Yeah.
Okay, so we're going to have inches on top of my UKSN. Let me go ahead and write that in. Oh, that's going to get squished. And then my bottom one, we are going to feet, because that's what we got. And I said there was what? There was 1 foot for every 12 inches. And how do I take it to there? We got to get it to 6 feet, right?
Mm-hmm.
Yep. So 1 times 6 gives me 6. What I do to the bottom, I have to do to the top. My goodness, it's all so squished. And then I know that 12 times 6 is 72. And that's going to be 72 inches.
Oh, that's the
Ooh, I see it.
That's an answer right here.
Woo-hoo.
Now, if I think logically about this, it can't be any of the other inches choices because we know it's only 72. So we can go ahead and mark out this 40 inches right here and this 55 and 5/10 inches because there's no way we can get there.
Love it.
So let's go ahead and make another UKSN. I'll change colors so we can hopefully see it better. UKSN. Oh. Okay. For this one, we have the 6 feet. So we know one of my units is going to be feet. And my other one is going to be my yard. So from my handy dandy formula chart, we know that there are 3 feet for every 1 yard. And we are trying to get to 6 feet. Whoop. I get 3 to 6 by multiplying by 2. So 1 times 2 is 2. So that means for every 6 feet, there are 2 yards.
Ooh, I
And
see
look,
it.
It's an answer.
it's an answer.
Boop, boop.
And again, that other one, there's no way it could be 2 1/3 because it says it's only 2 yards. So we can mark that one out.
Good job.
Good job.
Okay, next. Number 13. Oops, what's it? Okay, it says, the graph shows the amount of money due based on the number of bushels of corn that is bought. Which list shows the dependent quantities in the graph? Okay, well, I know a trick that Miss Kemp told me was, can I write the D here? Yes, I can, because that is the back. And then the I can write it down here. If I try to write the D down there, that's not going to work. It's going to be upside down. So now that we have dependent and independent, let's see, it's doing dependent quantities. Quantities mean numbers. So I know that I am going to have to find all of these little numbers. So let's see one that says that. And then our answer is A. Whoop, whoop. Let's see.
Keep going. Is that it?
Yeah.
Sorry. Sorry, I was just getting Number next, which is 14. The number of cupcakes sold at Whoops Bakery, that sounds like Miss O's baking, is displayed in the graph below. Which list represents the independent values of the graphed points? All right, so what do we do when we see a graph? Everybody, we have to label. So you have your X and your I for independent and your Y and your D. And I love the way Miss J said that. Here's your D bar, back bar, and here's your I top, okay? So they're wanting independent. So that looks like we're going to be looking here, right down this area, and it wants the values again. I want you to look at A choice, and then we'll just move on quickly. Look what they did, guys. 2, 7, 4, 14. They did every number. They went 2, 7, 4, 14. I mean, that's just ridiculous. Don't get caught up in their silliness, okay? Our numbers are 2, 4, 6, 8, 10, 12, 14, 16, and 18. Well, that leaves this one out, and I don't know what they were doing on C, and that makes our answer choice D.
Good
Woo-woo.
job. Question number
It's your
15.
own problem.
Oh man, I guess click the little finger and move this up. Okay. Question number 15. The table shows the relationship between B, the amount of money Miss Kemp has at the beginning of each day, and C, the amount of money she has after buying a Diet Coke. Oh my goodness, that Diet Coke habit's been with me for so long. All right, I'm going to label my table D, and this is my X values and my Y values. It looks like they're using different numbers or letters here, variables. They're using a B for the X and they're using a C for the Y, but I'm not going to let that stump me. Okay, they're looking for an equation. I know that equations always start with the dependent variable. So all of these start with C. Dang it, they did it again to me. Okay, well, let's look at what's happening from our X to our Y. We are getting smaller. Mr. Kemp is wondering what we're doing. We're getting smaller, so I know we're not adding. I'm looking at choice A. If we're getting smaller, we're not adding, so I'm going to get rid of choice A. So now I'm looking at choice B, and it looks like they're adding again and multiplying. We haven't done equations that have 2 steps now. Okay, I'm looking at C, and they're subtracting, which sounds good, but they're also, if you look closely at this, they're also multiplying because the number and the letter are touching. So I'm going to get rid of C. Oh my gosh, so that just leaves me with D, but since I'm such a mathematician, I'm going to check it really quick. And I'm going to say $15 minus $1.66. I gotta regroup here. Okay, so 4 and 3 and 3. Oh, $13.34. It works. My answer is D.
Woo-hoo. Halfway there, peeps. We're doing good. Okay. So let me write on that again. Oh, that's okay. It says, which of the following is an integer? You have to choose either integer or not an integer for each of them. So you have to choose one or the other, not both and not neither. Okay, I know that a integer is a positive and negative whole number. So all this means is it can't be a decimal or a fraction. Everything else is fair game. So negative 18 is a negative whole number. So that is an integer. 7, positive whole number. That's an integer. Negative 5 3/4. Ooh, that's a fraction. That would be a rational number. So that's not an integer. 4 5/10, a decimal. Again, we can't have decimals. That's a rational number. Negative 12 is a negative whole number. So that is an integer. Negative 6 3/10, again, no decimals. That's a rational number. That's going to go out, not an integer. And then 10 is a positive whole number, so that is an integer.
Woo-hoo, nicely done.
Okay,
I like that
number
problem.
next. Okay, the table shows the relationship between J and K, where J is the independent variable. So which equation represents the relationship between J and K? So first things first, I am going to label my table because I don't want to get confused. The top is always going to be my X, so I'm going to label it IX for independent. And then K is my Y, so that's going to be DY. So first things first, I'm going to go ahead and quickly glance at my answer choices because I know that K is my Y, and I feel like I can probably mark some out because our equations are typically Y equals. So we're looking for K equals. I can mark out B because it starts with J, and I can mark out D. So now we're only left with 2, so now we have to figure out what's happening. when we look at the problem, let's see, we're going to take 1 to 1/3. So looks like we're multiplying maybe or subtracting. So I'm not sure yet. Let's look at 2. Let's see. Looks like we are also doing something. You know what? This looks like we flipped a multiplication. Because if I multiply 2/3 by 3, I think we're going to be actually multiplying by 1/3. I think that's what we're doing, because if I multiply 3 by 1/3 over here, that gives me 1.
It does, you're right.
It does. So let's do it with 6. If I multiply 6 by 1/3, if I break that into 3 pieces, that does give me 3. So we are doing a multiplicative, and A has multiplicative. C is doing subtraction. And are we subtracting?
No.
No. So A is my answer on this one.
Okay, number next. We are doing number 18. What situation can be represented? Sorry, let me pull it up. Which situation can be represented by the equation y equals ax? Okay.
Multiplicative.
So let's read. Oh, yes, it is multiplicative. Let's make that. Okay. Charlie is y years old. He is 8 years older than x, his brother's age. Okay. So that looks like they are doing y as the outcome. And he is 8 years older than, so I'm pretty sure we are adding there.
Good job.
Oh, we're adding. That's not our answer. Okay. Number next. Let's see. Charlie ate X candies. This is 8 times Y, the number of candies that his brother ate. Okay. So last time we started off with Y. This time we're starting off with X.
No.
No, we never start off with X. Okay. Let's see. Charlie took X dollars to the football game. He gave his friend Y dollars and had $8 left. That means 8 would be our Y because that is the outcome of it. But Y is $1. No, that doesn't make sense.
No.
Nope, we don't like him. Okay, now the next one. Charlie has Y markers.
Yes.
This is 8 times
Yes,
X.
times.
Number of
Multiplicative.
markers. Yep, I think that is going to be our answer. Okay.
Wow, we just had to read that.
Oh, man. I kept thinking of the video, the Charlie bit my finger.
Charlie hook.
It really does. All right. I'm not going to lie to you. When you look at this one, it's really kind of hard to read. So just pay attention to the little bitty things, okay? The library charges 75 cents per day in late fees. Which graph best shows this relationship between the number of days overdue and the dollar amount of late fees? I always set up if I've got a graph, I try to set up a T-chart or something just so I know what's going on.
And this one, I kind of noticed that the axes are labeled different on some of the answer
Look at all the
choices.
different wording. So if this is my I and D and my X and my Y, but they're talking about days overdue, so I'm going to make that a D actually. And late fee, this is our money. So days and money. So 1 day would be 75 cents. 2 days would be $1.50. 3 days would be $2.25. Let's just go to 5. Is that okay with everybody?
Yes.
$3 for day 4. Day 5 would be $3.75. All right. So if I notice my ID, my I is my X, which is also my days. So let's see. Do we have days here? So we're good there.
Good there.
We're
It's on the
good here.
x-axis.
We're good.
Uh-oh.
Look at C and D.
See in here, no bueno.
No bueno
Switch
at all.
the independent and dependent
So
variables.
that got
Not
rid
good.
of 2. I love it. So now then, we just got to check our numbers, you think, maybe?
Uh-huh.
Let's look at 1 and 75 cents. Okay, that one's a little bit under. Let's zoom in just a wee bit. Little bit, This one, that one's above. I think we're done.
Yeah.
I think we're done. It cannot be this one. It would be answer choice A. I'll put it on the hand first.
Oh, thank you. Okay, so looking at
Last
the
time.
next one, number 20. graph shows the amount of money in Jack's savings, Y, based on X, the number of weeks. Which equation best represents the relationship between X and Y? Let's zoom in here on this graph. And I'm going to label my I and my D and my X-axis and my Y-axis. And I know if they're asking for an equation that we always start with the
Dependent.
Why? Because I like you. Why? Okay, so I need one that starts. Finally, I got one. Okay, this one does not start with Y, so it's gone. And this one does not start with Y, so it's gone. Okay, let me look back at my graph.
We've got
here.
an additive and a
We
multiplicative.
got an additive and a look. It goes through.
Goes through 0, 0.
0. So that's the origin, which means it is multiplicative.
Multiplicative.
So if I go back over here to my answer choices, I'm probably making you guys sick. I need multiplicative. Well, multiplicative means the number and the letter are touching. When things start touching, things start multiplying.
Why are we saying?
Number next, 21. Several numbers are placed incorrectly, in the diagram below. Circle 3 answers that are placed incorrectly. So I'm going to start with rational numbers. Oh, I think one of my numbers got deleted. We're going to start with rational numbers and then work our way in. Okay? So rational numbers are my decimals and my fraction. So 1.4 is a decimal, so he's good. Negative 16.365 is a decimal. He's good. And 1/2 is a fraction, so he's good.
Yeah. Rational.
There we go. Rational numbers are fractional. Integers, these are going to be positive and negative whole numbers, but if it's positive, it can go into the next category. So this is really only for the negative whole numbers. So no fractions and no decimals, and then the positive numbers are going to move down to whole numbers. So negative 6 is an integer. Negative 529 is an integer. I've got this 1/3 here. He's a fraction. Miss Kemp said rational is fractional, so he needed to be out here in the, oh my goodness. He needed to be out here in the rational circle. And then 18, it is an integer, but we can actually classify that one even further because it's positive. We can actually put that one as a whole number. And then I think on your packet there's an extra number. Mine got erased. -8. And that one is actually the last one that's not placed correctly because we can't have negatives in the whole numbers. Whole numbers are only positives. So this guy's got to move out to integers.
Okay, let's take a look at the next one. Rachel puts 2 and 592 thousandths kilograms of glitter into bags. She puts 24 thousandths kilograms of glitter into each bag. How many bags does she need? So it looks like we're separating something into littler things, which is going to be our kilograms. So it gives us our total here.
Ooh, if we have the total, we divide.
Yes. So we're going to take that and put it inside my house. I feel like I'm putting dots everywhere. My goodness.
I know. I don't know what. I would keep doing that too.
And then on the outside is going to go the 24 thousandths.
You're so good at reading that with place value. Dang.
Thank you.
Yeah, Miss Neal didn't do a great job on the
Okay.
last one. Ooh, bottom of the wall!
Yes. I'm going to change colors so we can see better, hopefully. We're going to move it 1, 2, 3. Move it to the wall. Now we have to do the same to the inside in the same direction. So 1, 2, 3. Now I have to raise the roof, and I'm going to also extend the line. Now we can actually do our division like a normal division problem. 24 cannot go into 2. It can go into 25 once, though. So that's going to be 24 minus 25, which is going to leave me with 1.
So B's already out.
Yep. We are going to drop down that 9, give us 19. Can't go in there, so we got to drop down our 2 and add our 0 up top.
Ooh.
Ooh,
That
I
is
think I see your answer.
192. I know 24 times 8 is going to give me exactly 192.
Nicely done.
So my answer is A.
Okay. Number next. Let's see. Put the little hand. Okay. 23 says, let's see. It says 4 points are labeled on the number line. Yep, we have M, A, T, and H. What point best represents point T? Okay. So it looks like I have fractions in my answer choices, and they labeled my number line to 0.5, which is 50 cents. Okay, I'm going to count how many jumps there is between 0 and 0.5 so we can know what to label these by. Okay, we got 1, 2, 3, 4,
5, 6, 7, 8, 9, 10.
Okay, so 10 in total. I'm going to divide that by 50, and that is 5.
5 cents.
Okay, so every one of these is going to be 5 cents. 0.5, 0.10, 0.15, and then 0.20. And I know I drew over it a little bit, but that is what we need for T. Oh, it erased the whole thing. Okay.
There you go.
Okay, so that is T, what we need, 0.20. That is in decimal form. We got to change it into a fraction, 20 hundredths.
Kill the zeros.
Simplify, kill the zeros, divide that by 2. That is going to be 1/5.
Well, 1/5. B.
Our answer is B.
Woo, woo.
Okay. Left it on the finger again.
Oh, thank you. Miss Kemp wishes I would do that. All right, next 24. Which point is not correctly placed on the number line? Point A, negative 18 thirds. Uh-oh, improper fraction.
Simplify.
18, that line means, hang on,
Divide.
to divide. So 18 divided by 3,
6.
6, and it's negative. Got it. I'm going to go check point A. Maybe it's it. No, it's correct.
No, it's right.
Darn it. Okay, let's go to C here because he's right here handy. Negative 15 6. Well, who's Ned? 15 is our Ned. He's going in the house, hopefully. There we go. Divide by 6. It will go 2 times. Subtract our 12. Miss O cannot write with this thing. 2 and 3/6. Ooh, I know 3/6 is a fancy fraction. He has a smaller, I'm so sorry about my 6. I apologize. He is equivalent to a half. So this one is really 2.
0.5. 5/10.
There we go.
And it's
All right.
negative.
He's negative. Thank you. Should we check point C?
Yeah.
Yeah.
Okay, so here's 2. Here we go. Uh-oh. Look, he's at negative 1.5.
You found it.
We did. So our answer is going to be point C.
Yay.
Yay.
Okay, number 25. The following table shows the relationship between x and y. Which of the following equations describes the relationship between x and y? Okay, so I see this table here and I'm going to label. This is my I and this is my D. I don't need to label the x and y because they're there. And look at that. They know that the equation always starts with y, the dependent value. Okay, I'm looking for a pattern here, so I'm thinking from an input of 1 to an output of 3.7. We're getting bigger, and I know that we're not multiplying, and I know that we're not getting smaller, so we must be adding. So let's try one of these. I'm going to start with this one right here and add 2.7. So my input was 1.0. I'm going to add 2.7 and I get 7 3.7. It worked. I'm going to check it one more place. I'm going to check it at the very bottom. I'm going to check down here. So I'm going to put in my 7, add 2.7, and I get 9.7. Oh, it works.
Woo!
So I'm going to get rid of this guy at the end here. So I'm needing y equals, oh, that x, sorry guys. I thought that was multiply. I need that x. How do I, okay, we got to, oh, okay. We're going to have to put that x. That x is going to go down here. That was our variable x. I thought it was multiply. Okay, now we're going to need this plus sign because we were adding. So I'm going to put a plus sign right there. And then we were adding a constant of 2.7. Y equals x plus 2.7.
Good job, Mia. Okay, number 26. Which statement about 3 multiplied by 2/3 must be true? So I'm taking 3 and I'm multiplying it by a regular old fraction. So I know that a fraction that's a proper fraction, what means that the numerator is smaller than the denominator. I know that my number must be getting smaller. If I multiply by improper fraction, that means that the numerator is bigger than the denominator, then that means that my number is getting bigger. So I can go ahead and mark out some of these answers. B says the product is less than 2/3. So if I'm starting with 3 and multiplying by 2/3, I don't think that's going to be less than 2/3. The product is between 2/3 and 3. I'm thinking that's probably true. The product is less than 2. I'm not really sure on that one. And the product is between 3 and 4. Well, it's not going to be greater than 3. And if we wanted to work this out, we could. I can multiply 3 times 2/3. Remember that every whole number has a denominator of
1.
1. When I multiply fractions, I multiply tops by tops, bottoms by bottoms. 3 times 2 is?
6.
1 times 3 is?
3.
6 divided by 3 is?
2.
2. So the product is not less than 2. So the only one that works is?
C.
C.
Okay, number next. Which equation is not
Not.
true?
Not.
So it looks like we're going to have to go through each of these. Let's
I
start
hope
with
you know
D.
your integer rules.
Yeah, let's start with D. I feel like we should start at the bottom every once in a while. So for this one, it is 8 minus -2. When we can't subtract, we have to do something to it called
KCO. Keep, change, opposite.
KCO. So we're going to keep our 8, change our subtraction to addition, and do the opposite of -2, which is 2. And 8 plus 2, we know that since it's 3rd grade, so 8 plus 2 is 10. Well, that one's true, so that one can't be our answer. Okay, the top one is -36 divided by -6. And when we divide or multiply, we have a special little man.
Dorito Man.
Called Dorito Man, if he'll ever draw. Whoop.
He's got a raised eyebrow. He's looking at you.
Okay, so what I like to do is I like to forget about the signs first and divide. So 36 divided by 6, that gives me 6. And I have a negative and a negative, so I'm left with a positive, and that checks out. So since it checks out, that one's not my answer because we're looking for the one that is wrong. Let's look at B. So again, we are multiplying here because there's nothing in between these two. So we're going to draw another Dorito Man. And so I like to ignore the sign. So 4 times 7, that is 28. So now I had a negative and a positive. So I was left with this negative over here. So -28, that checks out. So that one cannot be our answer. And let's double check this last one. We are adding. So my strategy is team positive, team negative. Woo. And -3 goes on the negative side. -7 goes on the negative side. When they are the same sign, we add. So 7 plus 3 is 10. But the team that won was negative, so that should be a -10. So our answer was A.
Good job.
Nicely done.
Okay, number next. Let's see. 28. A Gatorade cooler holds 42 gallons of Gatorade. The sports team used 3 gallons. Hold on, let me highlight stuff. Okay, 42 gallons. Ooh.
You pulled a miscount.
42 gallons of Gatorade. The sport team used 3 gallons of Gatorade each day. At this rate, how many days will it take?
Keyword.
Sorry.
How many days will it take for the cooler to empty? Okay. So it looks like they gave us the total, 42 gallons of Gatorade, and I think we're going to divide. Any objections?
No.
I do not object. I agree.
Okay, 3 goes into 4 ones, 3 minus that is 1, and then we bring down, and 3 goes into 12 4 times.
4 times.
And then no more left over. And that is 14 what? 14 days
Whoop,
each
whoop.
day. 14. Okay. Give me 1 second. Let me erase some of this for Miss O.
Thank you very much.
Oh, Miss O, you got a trap here.
I know.
They figured out a way to make you work 3 problems.
Rude.
Well, if you work 2 and they're correct,
Oh,
then
that's
it has to be the
Okay.
third one.
There you
right.
go.
Good
Good
call,
strategy.
call.
I mean, I'm just saying.
Hit them where it hurts.
Mathematicians are lazy.
Yes.
We're efficient but lazy. Complete the following equations by moving the answers. So this will be one of those click and drag, okay? Looks like we have 48 3/10 times 600 is equal to x. So we have our box down here. So we're just going to do it, folks. Maybe. We need a pen. 48.3 times 6. 18, 48, 9. I'm going fast. I'm so sorry. 24, but that is 28. Do y'all agree?
I agree.
Thank you. And zeros, oh, we have to drop that 0, but man, that's easy peasy. It's not going to be too bad. 9, 8, 2. What do y'all see?
Ball to the wall. Break
Yep.
the wall.
1, 2. Where's my 1 at? 2, 3. 1, 2, 3. Final answer 2.898,000.
Do I see it?
I see it.
I
Drag
do
it drop.
too. Good Lord, there's no way it's gonna write inside there.
You can write it underneath it.
2.898. So I got rid of that one. Now eraser is this one. This one. Thank you. Yes, Miss O's that challenged. We all know. My kids know. They're laughing. They know it's true. Thank you. All right, let's go 1.8. We should have done this one first. Look how easy it is. 2.3. 3 times 8 is 24. Carry that 2. 3 times 1 is 3 plus those 2's a 5. Drop my 0. Thank you. 0. 2 times 8 is 16. Carrying that 1. 2 times 1 is 2 plus that 1 is 3. 4. And another 4. What do we do? Follow the wall. 1. Let's see if we can get those. 1. Oh, look at them. They're being so nice. 1, 2. So 4.1.
Oh, I see it.
Oh, I do too.
Oh, you're right. You only had to do 2 of them, Miss O.
Because what's going to go in this box? Don't touch there.
16.
16. My kids would hear me saying, "Oh my gosh, Becky, come on, Miss O."
Yay.
Yay.
Number,
Okay, I can't touch the hand.
okay.
We got number last.
Number
last.
Woo! Woo! We made it. Miss Donathan. Oh, okay. Miss Donathan has 12 pieces of candy and she wants to split between 5 students. Ooh, I saw something. I feel like this is a total. So if we have the total, we're going to divide. Okay, and here's our other number 5 students. Select the correct representations to show how many pieces of candy each student received. Select 2 answers. Well, I know that when we're dividing, we can write that as a fraction with Ned as the numerator and donkey as a denominator. So we're taking our 12 pieces of candy, dividing by 5.
Oh, it's
Look,
an answer.
Look, guys, it's
B.
an answer. So B is an answer. I'm going to highlight that for y'all. B. Okay.
That also means E's out too, because
Yeah,
that's
that
the
gets
same
rid of
thing.
that.
Oh,
backwards.
good deal. I'm going to get rid of that. This is backwards. And I know I'm not doing A, 5 divided by 12.
No.
Because I'm starting with my total, which was 12.
Yeah, your Ned would get kicked.
Okay, so let's do our neato here. And I know 12 goes in the house.
No
And 5 goes outside. 5 will not fit into 1, so I'm not going to put anything on top there. But 5 fits into 12 2 times. Yeah, and that gives me a remainder of 2. I'm going to write this as a fraction. 2 fifths. Look at that, guys. That is an answer choice right here. So I'm going to get rid of D. And we have 2 answers, B and C.
Woo-hoo.
Study hard.
Y'all got this. Meet your goal. We'll have an incentive. Happy studying.